We're going to look at the definition of all of our different trig functions of sine, cosine, and tangent into three reciprocal functions. So if we have some point xy with our angle centered at the origin and our initial side on the positive x coordinate, and our terminal side would then be going to this angle here, we would then say r is your hypotenuse, which is a positive square root of x squared plus y squared. So in other words, r is always positive. If we go ahead and plot our point down here on the unit circle, we'd be x units over, y units up. So you could use the Pythagorean theorem to get your hypotenuse. So that's why we end up with this right here. And note, when you take the square root of this, it's plus or minus, but by our definition, r is always positive. Now, if you did think of Sohcahtoa, here'd be your angle, y would be your opposite over your hypotenuse, and you know opposite over hypotenuse is your sine. So it's really just applying your Sohcahtoa formula to your general definition right here, or cosine, which is adjacent of x over your hypotenuse of r, and that's what we have right here. Oh, and then we have tangent. Tangent's opposite of y over adjacent of x. And then, of course, we have the three reciprocal functions underneath, which reciprocal of sine is cosecant, so you flip it upside down. Reciprocal of cosine is secant, which so you flip that upside down. Reciprocal of tangent is cotangent, so you flip it upside down. Now, all these that have x and y in the bottom all have this because we can't divide by 0. Another thing on the side you should know is our three main Pythagorean theorem identities of sine squared plus cosine squared equals 1. 1 plus tangent squared equals cosecant squared, and tangent squared plus 1 is equal to secant squared. Those are all related to your Pythagorean theorem for your circle over here. So, suppose you were given this right here. Fits to our definition. We have our x, we have our y. We could go ahead and go x squared plus y squared equals our hypotenuse squared, and we would get 17. Remember, r is always positive. You could just use your definition from the previous page and go y of negative 15 over r. You could go your x of 8 over r. You could go y over r. And then you could do the three reciprocal functions. So flip your tangent upside down to get cotangent. Flip your cosine upside down to get your secant. Flip your sine upside down to go get your cosecant. Nothing wrong with thinking of it that way, but another way you could think about it is plot this point, 8 to the right, 15 down. Your hypotenuse would be 17. When you draw yourself a triangle, you always go to the x-axis. Always to the x-axis. Never to the y. So you go from here straight up to your x and form a right angle right here. Your angle is always in the triangle at the origin. And then if you wanted, you could just do Sohcahtoa. So if you were doing your sine, that would be of your angle, that would be opposite over hypotenuse. And that's what we had here. You could do your cosine, which would be your adjacent over your hypotenuse, and well, that's what we had here. You could even do your tangent, which is opposite over adjacent, which you have here. So Sohcahtoa even works with this. And a lot of times, instead of trying to remember that definition, I'll just go ahead and use Sohcahtoa. But there's nothing wrong with using that definition. Quadrantial angles are the angles that land on your axes. Well, the first one over here would be 0, then it would be 90 here at the top. And then if you come all the way around, you know that that's 180. Go around to the bottom, it's 270. All the way around, it's 360 degrees. And then you could keep going and have that all work for you too if you wanted. Now here we have one of our quadrantial angles of 180. So if we look at this, we would then be, sorry about that. This would be the coordinates because we're going something left and we're going up and down 0. Now, if you go ahead and use your formula for finding out what r is, x squared plus y squared equals r squared, so you would get this. Once again, r is always positive. So here, drawing a triangle doesn't work because we're right on one of the axes. So if you're right on one of your axes, you do have to use your definition. So you'd have to go your y, which is 0 from your point over there on your graph, over r, and 0 divided by anything is 0. Then you could do your cosine. Cosine is your x, which according to your this over here is negative r, over r, which is down here, you would get negative 1. Tangent is your y of 0 over your x of negative r. 0 over negative r is 0. And then, of course, we have to do our reciprocal function. So you got to flip tangent upside down. I'm going to flip this upside down. And then that gives me 0 on the bottom. I can't have 0 on the bottom, so I know that's undefined. When I look at cosine and flip that upside down, I will get still negative 1 for my reciprocal function of the secant. And then up here, I'm going to flip this upside down for my sine. Flip that upside down, I get my cosecant. Get 0 on the bottom, so it's undefined. So here we're going to talk about reference angles. Reference angles is basically how far you are from the x-axis. And it's acute, meaning your angle has to be between 0 and 90. So looking at this, your reference angle is how far you are from the x-axis. 180 puts you over here. Well, if you went all the way, that would be 180, but you only went to 160, so you'd be 20 away, so your reference angle would be 20 degrees. Looking at the next one, you're 110 degrees back, so if you go from there to the x-axis, that would be your reference angle. If you went backwards all the way to there, that would be 180 back, but you only went 110, so you're 70 degrees away. Looking over here at the next one, your reference angle would go from here to here. We always have to take the shorter route to the x-axis. We would not want to go ahead and go the longer route to the x-axis because, according to this, it has to be acute, meaning less than 90. So this one here, then, if you're at 275 to get to here, you would then be 85 away. It even works when you're dealing with radians. Your reference angle, once again, is still that shortest one. Now, you know if you go backwards the whole way, that's a full pi, but we only went 3/4 of the way, so a full pi minus 3/4 of a pi, which is 1/4 of pi, would be your reference angle. So now we're going to go ahead and use reference angles to help us out to evaluate this. If we look at cosine of negative 60, we know negative 60 puts us approximately here. The reference angle is nice because all we have to do is just remember stuff from the first quadrant that you're supposed to have memorized from Unit 1, or Trig 1. So you're 60 degrees down, so your reference angle is 60. So all we have to do then is just remember cosine of 60. Well, cosine of 60, we know, is 1/2. The question now is we have to decide if it's positive or negative, and you got to think, does cosine deal with x or y? And from our definition, cosine deals with x, and we know in this quadrant your x is positive. Looking at this one here, you're 5 pi over 4 to here, you're going back to here for your reference angle, so that's 1/4 of a pi. By the way, anything pi over 4 would have a reference angle of pi over 4. Cosine of pi over 4 you're supposed to have memorized because that's the same as cosine of 45 degrees, and that's root 2 over 2. You now have to decide if it's positive or negative. When you're over here in this location, you know your cosine, which is x, is negative because you're going to the left to get to it. So you just put a negative in front. cotangent of negative 150. So cotangent negative 150 rotates to here, means you're 30 degrees from the x-axis, so your reference angle is 30 degrees. So we need to look at the cotangent of 30 degrees. Now cotangent's not one you're supposed to have memorized. You know that that's the reciprocal of tangent. So all we're going to do is write down the reciprocal of the tangent of 30. Tangent of 30, you know, is root 3 over 3. We want the reciprocal, so I'm going to go 3 over root 3. And then once again, you know you can't leave the root in the bottom, so you're going to multiply by a special form of 1. You'll get 3 root 3 over a 3, which is just this. Looking at this one here, you go backwards 2/3 of a pi, means you're a third of a pi away from here. By the way, anything pi over 3 would have a reference angle of pi over 3. So we have our reference angle of pi over 3. Instead of dealing with cosecant, which I don't have memorized, I'm going to deal with its reciprocal, which is sine. I do have that memorized. Sine of pi over 3, which you know is the sine of 60 degrees, is negative, well, we know it's going to be negative. We'll talk about that in a bit. Root 3 over 2, but it's 1 over that. But you know, instead of taking 1 divided by a fraction, you could take 1 and multiply by the reciprocal. So it'd be 2 over root 3. Not wanting to leave the root in the bottom, we rationalize it, and we get this. But now, why is it negative? Well, we're in this quadrant right here. We're dealing with cosecant, which deals with sine, and according to our definition, sine deals with y. And the y in our third quadrant is negative.